We have got our left side engine bay piece here, left third, and it's all fabbed up. I've cut the piece off of the existing one that I liked. I just didn't want to have to fab up all of this through here. Bending this on an arc would have wanted to make this warp. I really wanted it nice and flat. You can get it flat, but I thought, you know, it's probably just faster to cut it here, so I cut it there. Just want to show you our gaps. We're going to be MIG welding this together. Gap's pretty tight through here all the way along, and as I tack this, I'll move these pieces in closer. The closer you can get that gap, the better off you are. I know Harbor Freight and some of those places sell these clamps right here, and I've bought them, and they work really great for some things. They sell them and tell you that you should have a space in your panel. My experience has been the closer you can get the two panels together, if you can get them airtight, your weld is going to be much smaller and cause less heat distortion. And in the end, that's what you're very concerned about when you're welding any kind of metal, and especially if it's supposed to be flat and stay flat. If you have a little curve, sometimes it's easier for the curve to absorb the heat than it is for the flat pieces. So I've also got a piece of brass behind here. That's just as a heat shield so I don't burn up my bench. No big deal. I wanted to show everybody out there on the web the equipment I use to weld together the sheet metal. This is a Hobart Handler 130. It's plenty big enough machine to weld sheet metal. It's got voltage controls here. It's a little bit lacking in that it only has 4 settings around here. I always have it set on 1. That's the least amount of voltage. Then this is our wire speed. I have it set somewhere around 2 o'clock, 1:30, something like that. And that's just over time testing what works the best for sheet metal. That's where I've had it. I've got a couple extra plugs here and a switch that you don't see on most Hobart handlers. I fabricated a system to do aluminum spool welding out of this machine with another solenoid and a spool gun. That's not standard equipment. Over here I've got CO2 or C25, sorry, which is, I believe, 75% argon, 25% CO2. This is the gas you use when welding steel. I would not recommend flux cord wire for sheet metal. It just doesn't work. Over on our piece, I've got my ground clamp and my MIG gun here. Generally, I'll cut the wire off before I start so I get a nice clean start. The other nice piece of equipment to have if you're going to be doing sheet metal work, you do so many spot welds when you do this. It's nice to have an auto darkening helmet. This one's just a Harbor Freight cheapie. I've bought a couple of these. The batteries kind of go out. They're really, you got to crack them open to change them. It's just cheaper to buy a new one. I think they're 20 bucks or something like that. So you can go through about 5 of these or 6 of these for the price of a really nice Hobart or Miller or Lincoln helmet. When you're welding the sheet metal, some people will come right over the top like this, point the gun straight down. That makes about the most heat possible. I tend to like to make the least heat possible. What I found works really best is to come off to the side with your gun and line up the nozzle with the joint that you're welding. So just line it up, come down at a nice low angle, and when you do that, it'll keep the weld nice and cool and you won't have nearly as much burn through. Welding here on the bench with brass behind, I don't think we'll have any trouble with burn through, but if you're welding on a car, it becomes very important. The more upright you get and the more straight on, the more heat that's going to create right in the puddle. The other thing to keep in mind as you're welding is the distance of the tip from the tip to the work. If you're very close to your work, it's going to be hotter. As you move further away, it's going to cool off. So if you're trying to fill a little bit of a void, sometimes if you lift your gun up maybe another 1/4 inch and pull the trigger in real short bursts, you can actually fill things without burning through. The first thing I did with my welder, before we get to the welder, one of the most important things to do is work with clean metal while you're welding. you can weld through paint, so on and so on. Your welds won't be near as clean as if you just take a grinder real quick and hit the edges of what you're welding before you do. The first things I did here, I tacked it in this corner because this didn't fit, the gap here didn't fit exactly like I wanted. So I tacked it in the corner, pushed everything together, made another tack, worked my way this way because I wanted the metal to push out this way and get this lined up. It wasn't quite there, it was really close, it was within half a millimeter or so, I don't know, a couple thousandths of an inch, but just where it wasn't where I wanted it. Now it is. So what I'll do is I'll go back and I'll fill in between each of these welds, and as I get that done, I'll go back again and fill in between. And while I'm welding, I like to have my compressed air nearby. So as I'm welding, I weld probably 4 or 5 spots, hit it with the air, keep everything nice and cool. Very important to keep things cool. If you heat up, it will buckle and warp on you. So the cooler you can keep it, the metal will relax quicker and you can actually work faster this way. So here's the finished product. As careful as I was on this, I knew it was a pretty small piece of metal and it's supposed to be perfectly flat. I got just a little bit of a bubble in here, so I'm going to have to shrink that out. One way I might do that is when I grind these, if I can build up just a little bit of heat and cool it off, sometimes that'll take some of this out. What I'll probably do is clamp this piece to the bench so that as it does cool off, it'll stretch and tighten to the shape that I clamp it to. We'll see. If not, I do have the support rail from this piece that needs to go on there, and when I weld it down, it may take some of that buckle out as well. All the welds are ground here, and after grinding the welds and having this clamped down, I've still got just a little bit of a bubble under here. So I'm going to show a different technique for shrinking metal, and it involves, I think most everybody's seen the shrink disc on the internet now, but what you can do is just take a scrap piece of metal here and your grinder, and it's going to take me 2 hands, so I won't be able to hold the camera. But what we're going to do is we're going to grind on this metal and get it warm. Then we're going to take it off and blow cold air on this, and it'll cause the metal to shrink just like using a torch and heating up a piece and cooling it down, that sort of thing. But you can do it with an angle grinder.